Hi everyone. In this video I'm going to demonstrate how you can test for mediation using Andrew Hayes process macro, but rather than relying on the built-in templates that are typically accessed by users through the drop-down menu, I'm going to be showing you how you can build and test your own customized models using some fairly simple syntax. Now before I get started, I do want to mention that underneath the video description you'll find a link to the SPSS data file that I'll be working from in this presentation, so you can download the data to follow along. You will also find a link to the PowerPoint that I'll be referencing throughout this presentation. Next, I want to mention that in this presentation I'm not going to be going over output or spending time interpreting results. At this point I'm going to make the assumption that you have some background in mediation analysis and are mainly interested in building and testing your own customized models using the macro. And the final thing that I want to mention is that in order to use the macro it needs to be installed. So if you haven't already installed the macro, you're going to want to do that because the syntax is not going to work if it's not already installed on your SPSS. If you don't have it installed but you would rather use the syntax file that is incorporated or included in the zip folder that is downloaded from Andrew Hayes' website, you can easily use that to activate the macro and then use the syntax that I show you in order to run your customizable models. So for our demonstration we are going to be using data from an article by Zhao et al. Entitled Relationship Between Anxiety and Burnout Among Chinese Physicians, a Moderated Mediation Model, and this was published in 2016 in the journal PLOS ONE. So we're not going to be working with moderated mediation in this demonstration. We are just going to be using the data in order to test various customized mediation models. And the variables that we will be working with include extroversion, neuroticism, burnout, positive coping, negative coping, and anxiety. So the first model that we are going to be testing is actually consistent with template number 4 that can be accessed through the drop-down menus. But you'll see right here that we have syntax that is given, and the main point of this walkthrough is just to kind of show you how to set up the syntax in order to run this model if you wanted to use syntax instead. And then from there we'll build off of that in order to test various other models. So really quickly, just taking a look at our model, we have burnout serving as the independent variable, anxiety serving as the dependent variable. We have positive coping and negative coping serving as proposed mediators of the effect of burnout on anxiety. So all of the single-headed arrows represent direct effects within the model, and the indirect effect of burnout on anxiety is actually incorporated into two specific indirect effects. So the first specific indirect effect is calculated as a product of paths A1 and B1, and then the second specific indirect effect is calculated as a product of paths A2 and B2. So the total indirect effect of burnout on anxiety would be calculated as a sum of those two specific indirect effects. So getting on with our syntax, you'll notice down here I start off with process. So this is going to activate the process macro for use. Then we follow that up with y equals and then the name of the dependent variable in your model. We have a /, then m equals, and then we have the names of our two mediators. So positive coping is our m1 and negative coping is our m2. Then you see we have a /, then x equals, and then the name of the independent variable burnout. Then we have another /, and now we have the option total right here, which I've set equal to 1, and that gets you the total effects for the model of x on y. Then another /, then I have stand equals 1, and that is going to generate standardized regression coefficients in our output. So in addition to having the unstandardized regression coefficients and significance tests, we can now get those standardized coefficients. We follow that up with a /, and then we're using B matrix right here. And basically, we have B matrix equals, and then we have values of 0 and 1 separated by commas. And this is specifying the model. So this is where we would specify our customizable model. And then finally, we end with a period right here. So let's talk about these coefficients right here. Those coefficients are actually coming from this table that I've set up, where we have laid out the source of various effects within the model, and then those outcomes that are receiving effects from source variables. And it's a good idea when you are laying out customizable models, not only to perhaps draw out your model, but then also to set up a matrix such as this to help populate the B matrix option down here. So looking at this matrix right here, you'll notice that I've got X, M1, and M2. And so these are reflecting the source of effects. So you'll see that we have burnout that is predicting M1, and burnout's predicting M2, and then burnout is predicting our Y variable right there. So X is clearly a source variable in our model. We have M1, which is predicting anxiety right here, and so that is clearly a source variable. And we also have M2 serving as a source variable within our model. So what we need to do then is in order to generate our coefficients, is we need to look at the intersection between each source and outcome. So we'll start off with X. So X is predicting M1 and M2 and Y. So again, we have X is our source variable. We're predicting M1, M2, and Y right here. So we're giving coefficients of 1 for each of those effects, because X is predicting each of those variables. Then when we move to M1 right here, you'll notice that we have a dash right here. This is it. Basically, there's no value that we are putting right there. We're not putting a 0 or a 1 there. Instead, you'll see that we have M1 and M2, and I've set this equal to 0. So if you can imagine, this would be equivalent to, assuming that if we did have an arrow drawn from M1 to M2, that would be essentially fixing that path coefficient equal to 0. So that's why we have 0 given right there. And then we have M1 predicting Y. So that's reflecting this, this path that's being estimated. Then finally we have M2. And again, we have our first couple of lines right here that are dashes, which is indicating that basically M2 is not predicting M1, and M2 is certainly not predicting M2. But instead we have M2 predicting Y right here. And so in that case, we are fixing that, or we're setting that coefficient to 1. So those are the values that are being incorporated in our B matrix option right here. So the way this works is just to simply follow this kind of approach. We just start off with 1, then 1, 0. So we have 1, 1, and 0. Then we have 1, 1, and 1. So you'll notice that we're proceeding across the rows, and then once we've finished the coefficients in one row, we move to the next row and enter the coefficients there, and so forth. So that's how that works. So now let's go ahead and open up SPSS and use the syntax in order to generate our output. So now I have SPSS opened up, and I'm going to go to File, New, and go down to open up syntax. So this is the syntax editor. And keep in mind, again, that you need to have the macro already installed, which I do right here, or you would have to use that syntax file in order to activate the macro in order to use the syntax in the way that I'm going to be showing you. So in the syntax editor, what I'll do is I'm just going to go ahead and put the syntax in. You would just need to type that up. And so I've got the syntax already entered right here. So again, process, this is going to activate the macro. I have y equals anxiety / m equals pos cope and neg cope with a space in between. Follow that up with a / x equals burn. Followed that up with a / total is equal to 1 / stand equals 1 / B matrix, followed by the coefficients, and then make sure that there is a period at the end. So I'm going to go ahead and highlight this and run it. And we have our output. So really quickly, you'll see up here, this is just where I have the syntax in my output file right here. And you'll see in terms of the output associated with process, it says model, it says custom right here. Y is anxiety, X is burnout, M1 and M2 are positive coping and negative coping. There's our sample size. And then as you scroll on down, you get the output associated with that model. Again, this is the same output that would be generated if we were going through the drop-down menu option and had set it up for model number 4 right there. Okay, so now let's say that we do not want to have a direct effect of burnout on anxiety in our model. So this is where I've got a second model that's laid out. So in here we've got the effect of burnout on anxiety proposed to be fully mediated through positive coping and negative coping. So now in terms of our B matrix option right here where we're setting up our coefficients, let's take a look at our matrix that I've set up right here. So in this case, you'll notice that we have X. Again, that's predicting M1 and M2, so those coefficients are set to 1, but we're not having a direct effect of X on Y. So in that case, the coefficient is set to 0. And then the remaining coefficients are exactly the same as before. So we have M1 not predicting M2, so that coefficient is 0. We do have M1 predicting Y, which is fixed to 1, and then we have M2 predicting Y as well. So now let's run the analysis using this syntax. So I'll go back into my syntax editor. I'll just go ahead and keep that first one there, and I'll paste this one in right here. So again, everything that we have up to this point is exactly the same as what we had in the first analysis, but the B matrix, the coefficients that are given right here are slightly different, and the main difference pertains to the effect of X on, or the direct effect of X or burnout on anxiety, with that difference reflected in this coefficient here. So the first model, it was a 1, this coefficient here is a 0. So when I highlight this and I run it, we now have our output. So again, this is a custom model. All of this information is going to be exactly the same. You can see that we have basically our submodels, regression submodels, where positive coping is regressed onto burnout, negative coping regressed onto burnout. These would be exactly the same as the previous model, or model number 4. The last one though, we have anxiety, and you can see right here that it is regressed onto positive coping and negative coping, and burnout's not included, whereas when we ran this analysis using essentially model 4, burnout would be included as a predictor alongside positive coping and negative coping. Okay, so now let's try a different model. So in this case right here, we have both serial and parallel mediation. So the effect of burnout on anxiety is being mediated through positive coping and negative coping. So, and then we also have positive coping now predicting negative coping. So in terms of our matrix right here, you'll notice that we have X, which is predicting M1 and M2, so those values are set to 1. But you'll also notice that we do not have a direct effect of X on Y, so we're leaving this coefficient set to 0. Then we have M1, and now M1 is predicting M2, so it's this path right here. So now that coefficient is set to 1, and we still have M1 predicting Y, so that coefficient is set to 1. Then we have M2 predicting Y, so that last coefficient is reflecting that direct effect right there. So in terms of the coefficients then that we are going to include with the B matrix option, you'll see that we have 1, then 1 and 1, so that's the first 3 ones right here, then a 0, that one right there, and then we have 1 and 1 right here, so those are the last 2 ones. So now let's run this model in SPSS. So I'll go ahead and paste that syntax in right here that I've written, and again, the only difference in syntax from the first two is is concerning these coefficients that are given associated with B matrix. Once again, make sure there's a period at the end in order for it to run. So now I'll highlight this and click on the green button to execute it, or execute the analysis. And so now we have, again, it says custom up here. All of this information is exactly the same as before. But now when we look at our output, you'll see that now we have positive coping regressed onto burnout right here. And then in the next model, you'll see that we have negative coping, but in this case, it's regressed not only onto burnout, but also onto positive coping. So that's the additional path that we had included. And then finally, when we scroll down a little bit further, we have anxiety, which was regressed onto positive coping and negative coping. Burnout is not included because we did not incorporate a direct effect of burnout on the anxiety variable. Okay, so now let's consider a model. Let's take a little bit of a permutation on that last model where we add in a couple of covariates. So in this case right here, we're going to be adding in COV equals and then the names of the two covariates in our data set, which are going to be extroversion and neuroticism. So everything else is going to be exactly the same as the model we just ran, but we're adding in COV equals EXTRAV for extroversion, and there's neuroticism. So you'll notice that I do have in this slide right here, I've got COV underlined. There's no underlining in the actual syntax. I'm just using that to highlight the fact that we are incorporating covariates in our analysis. Okay, so I'll go back into my syntax editor right here, and I've gone ahead and copied and pasted the syntax in. So I'm going to highlight all of this, and once again we've added in covariates. So now when I run the analysis, again it takes a couple of seconds to run, and now looking at our output, you'll see that here we still have custom right here. There's anxiety, burnout, positive coping, and negative coping. That is reflected right here, but now it says covariates. There's extroversion and neuroticism that are given there. So now when I scroll down, you'll see that we have the first regression model is positive coping, where positive coping is regressed onto burnout as well as the two covariates. So there's extroversion and neuroticism there. Then when we scroll down for negative coping, you'll see that we have negative coping regressed onto burnout as well as our two covariates here. So and also positive coping, because we incorporated that direct effect of positive coping onto negative coping in this model. So then when we scroll down a little bit further, you can see the last model where we have anxiety as the dependent variable. So anxiety is regressed onto positive coping, negative coping, as well as those two covariates. Now I did want to show you another couple of options that you might choose. You'll see right here I've got the boot option, as well as this right here, the CONF. This is for confidence intervals. The default in process is 5,000 bootstrap resamples and 95% confidence intervals, but I wanted to show you that it is possible to change those defaults to, like in this case where I'm setting it to 1,000 for bootstrap replications and then 99% confidence intervals right there. So we're going to run the same model as before, but in this case we can add in those options. So we'll go down here. I'm just going to paste that in right there and highlight, and then click my little green arrow button there. And so pretty much most of the output, or all of the output for our models is going to be the same, but in this case the difference concerns the confidence intervals that are formed and the number of bootstrap replications. So you'll see down here it says number of bootstrap samples is 1,000. And also you can see level of confidence for all confidence intervals is set at 99%. So previously when we ran our analysis, the number of bootstrap samples again was the 5,000, which is the default, and the confidence interval was set at a default of 95%. Okay, so now let's look at another model. In this case, this is going to be consistent with model number 6. So in this case, we have burnout serving as a predictor of positive coping and negative coping and anxiety. But then also we have positive coping predicting negative coping right here. And we have positive coping predicting anxiety and negative coping predicting anxiety right there. So basically, this model is incorporating serial mediation. So let's take a look then at our matrix that we've created right here. So we have X predicting M1, so that path right there. So we fix that coefficient to 1. We have X predicting M2, which is this path right here, and then X predicting Y, so we have a coefficient for this path of 1 there. Then we have M1 predicting M2 right there, so this path, so we're setting that coefficient to 1, and then M1 predicting Y, which is this path right here, so we're setting that coefficient to 1. Then we have M2 predicting Y, so we're dealing with this path and we're fixing that coefficient to 1. So now you can see that where we have B matrix, we're setting that equal to 1, 1, 1, 1, 1, 1, and then again we have a period at the very end. So going back into my syntax editor, I'm just going to go ahead and paste this in as well, and we'll go ahead and highlight it and run the model. So we'll click on our green arrow again. So you'll notice that we did not incorporate those covariates that we had before in our previous model, and we also are sticking with the defaults of 5,000 bootstrap samples and 95% confidence intervals. But kind of looking at our output, you can see there's positive coping regressed onto burnout. Then when we scroll down a little bit further, we've got negative coping regressed onto burnout and positive coping right there. Then when we scroll down a little bit further, you can see that we have anxiety, which was regressed onto burnout, positive coping, and negative coping right there. And then for our last model, we'll look at kind of a reduced version of model number 6, where in this case you'll notice that we do not have positive coping predicting anxiety, and we also don't have a direct effect of burnout on anxiety. So in this case, basically we have X predicting M1, X predicting M2, X is not predicting Y, so we fix that coefficient to 0. Then we have M1 predicting M2, so that coefficient is 1, but M1 is not predicting anxiety, so we're giving that coefficient a 0. And then we have M2 predicting Y, so we're giving that coefficient a value of 1. So these are the coefficients for this particular model right here. Okay, so now I've generated the output using that syntax. So in this case we have positive coping regressed onto burnout. That's the first model that's given. Then we have the output where we've regressed negative coping onto burnout and positive coping right there. And then the final model where we have anxiety regressed only onto negative coping because we had essentially fixed the paths from burnout and positive coping to anxiety to 0. So that's where we'd use those 0 coefficients in our table. So that pretty well concludes this video presentation, and I appreciate you watching.